Hello everyone, welcome to Study Made Easy, a smart learning for a smartphone generation. Now today we'll be continuing our discussion on kinematics, and in this video I'll be discussing projectile motion with you. Now I have made already some highlights of what we are going to discuss in projectile motion. Now first we'll discuss that what is a projectile motion. Then we will derive the equation for a projectile. We'll talk about the time of flight of a projectile, range of a projectile, and the maximum height reached by the projectile. Right? So let's go and define what is a projectile motion. Now basically, projectile motion, it is an example of two-dimensional motion in which a particle actually is being thrown at an angle theta with respect to the surface of the earth. And the particle that is being thrown, it travels a curved path until it finally touches the ground. The particle which travels this curved path is known as a projectile, and the motion it travels, it is known as a projectile motion. I hope you have got it. Now let's talk few terminologies in projectile motion. Now you can see that the point O from where the projectile is being thrown is known as the point of projection, and the distance, the horizontal distance the projectile covers until it finally touches the ground is known as the range of the projectile. So here OB is actually the range of the projectile. It is the range of the projectile, right? Next thing is that the distance AC is known as the maximum height for a projectile. So AC is the maximum height for a projectile, right? And the time taken by the projectile in traveling this distance, or I can say in traveling its motion, is known as time of flight. Right? So let's move and first derive the equation of projectile. But for that, let us write equation for acceleration in its component form first. Now A, acceleration, can be written as in its component form as ax I unit vector plus ay j unit vector. And let us write velocity into its components form. Now note here that the projectile is being thrown with an initial velocity of u. So the initial velocity can be written into its component form as uxi unit vector plus uy j unit vector. Right? Now notice, let me say we have a projectile here. Our projectile after some time is reached here. Now notice that the only force that is acting on the projectile is gravity. So the only acceleration the particle can have will be acceleration due to gravity g, and that is acting in y direction, right? So there will be no acceleration along x-axis because there is no force present in that axis, right? The only force that is present is the gravitational force, and that is acting along y-axis, and that causes an acceleration due to gravity g on the body. So from this I can say that ax will be equal to 0 and ay will be equal to g, right? Now further notice that since acceleration along x-axis is 0, there cannot be a change in the velocity, or I can say in the x component of the velocity. Why? Because we have defined acceleration as a rate of change of velocity. Since acceleration is 0, there will be no rate of change of velocity. That means velocity will be constant. So what we conclude from this is that velocity along x-axis will be constant throughout the motion. It will be constant throughout the motion, and no doubt uy, the velocity component in y direction, will change, right? It will change. Now notice that, let me say at this point we have a velocity has this direction, and I can write its component form as simply ux and simply u of y, right? Now since uy is acting upwards and gravitation is acting downward, now what will happen due to this, that the velocity component in y-axis will continuously be decreasing, because both vy and g are acting opposite, right? So what will happen, as the time passes, as the projectile covers its distance, what will happen is that velocity in y component will continuously be decreasing until a point where it will be completely equal to 0, and that point is the maximum height reached by the projectile. So at the point A, only the horizontal component of the velocity is present and no y component of the velocity is present. So at maximum height, uy is equal to 0, right? Now what happens after this, that since now after this the y component of the velocity and acceleration due to gravity are in the same direction, there will be a continuous increase in the y component of the velocity until it finally reaches the ground, right? Now having understood this, let us first derive the equation of projectile. So let us derive equation of projectile, right? Okay, now since velocity is constant throughout the motion of a projectile, we know that speed, that is velocity along x-axis, it will be simply equal to u cos of theta. We know this, right? Now what happens, what will be the distance traveled by the projectile in time t? Now we know speed ux is equal to distance traveled, let me say it is equal to x divided by time t, right? So the distance traveled will be simply equal to ux into t. So I can write x will be equal to ux is equal to u cos of theta into t, and from this t will come out to be simply x divided by u cos of theta, right? So this is the time taken by the projectile in covering the distance x, right? Now this is the distance traveled in x-axis. Now from the second equation of motion, we know that the distance traveled in y-axis will be simply equal to uy into t plus half of ay into t square, right? So y can be written as uy is actually equal to u sine of theta. You must be knowing that. So u sine of theta, and for t I will write x divided by u cos of theta. So I will write it here, x divided by u cos of theta plus half of. Now notice here that since the projectile is moving upwards and the acceleration due to gravity is downwards, and for downward, if the body is moving upwards, we substitute ay as negative g, right? So I will write it here as minus g, and for t I will write x divided by u cos of theta raised by whole square, right? Now here notice that u and u will cancel out and y will be equal to simply x tan of theta minus half of g x square divided by u square cos square theta. So now this is my equation of projectile, right? So I think you have understood this.